So yeah, my name is Matt Shaffer. I'm the director of AI and a co-founder at RIOS Intelligent Machines. Um, Put simply, RIOS builds intelligent robots for smart factory automation, which involves some very difficult problems. We'll get into a few of those today. But RIOS, along with a lot of many, or along with many robotics and AI startups, is generally considered to be in the class of companies that are referred to as deep tech. And if I can scroll to the next slide. Right, hold on one second. That does not seem to be working on the. That's going all the way to the end. Let's see. I've lost my controls to the slides here. Let me try to reshare one more time. One moment. Sorry about this. I've never streamed on this platform before. All right, let's try that. All right, are you seeing the slides now?
Yes.
All right, and it should say deep technology. Yes, okay, I see it. All right, sorry about that. All right, so as I mentioned, RIOS, along with many other robotics companies and AI startups, are generally considered to be in the class of companies called deep tech. If you go to Wikipedia and look up the definition, this is what it says here. There's a few things to point out, and the first thing I actually want to point out is the date that this was last edited. So this was edited back in 2020, and that was before the recent economic events that kind of changed the way people have been thinking about startups and investing. So, part of this definition is that deep technology requires some substantial scientific or engineering challenges, and you can definitely apply that to a lot of the work that we're doing, as well as other startups in the field of artificial intelligence, machine learning, robotics, and so forth. The other thing here that they say is that the primary risk that these startups undertake is technical risk, and while that may be true, there's also market risk in any startup, but they do say that it is significantly lower due to the clear potential value of the solution to society. And I think that's one of the things that I'd like to talk a little bit more about today, in terms of how we view machine learning startups in particular, and what it really takes to build out a business. And so, they downplay the market risk due to this clear potential value, and I think we're gonna look a little bit deeper into that. And so, if you look at the investment over the last decade or so, in terms of uh, deep tech investments, as we're looking at here, the growth of deep tech has been pretty substantial. So between 2016 and 2020, you can see that the deep tech investments grew from about $15 billion in 2016 to about $62 billion in 2020. And the projections for the next few years show it growing to about 200 billion in 2025. So, again, the the time at which these projections were made is a few years ago, back in 2021, when there was still a lot of optimism around the deep tech industry and really what the potential payouts were going to be. If you start to look a little bit more recently, you can see that there was an inflection point in around 2021, 2022, where the recent economic downturn marked a change in investor sentiment. And if anyone has tried to raise money in the last 6 months, you may have noticed how differently investors are thinking about what makes a good investment. And this quote here represents the more recent criteria that venture capitalists and early stage investors are using to make decisions about investments. Previously, there was a class of investors called tourist investors, which were investors with cash coming in earlier stages than they usually would. And investors are telling us that those days are gone. Investors now want to see a clear path to profitability. But the question I want to look at here is, what does a path to profitability look like for these deep tech startups? But before we do that, let's just reconsider what deep tech means. And without the optimism that the Wikipedia definition gave around overcoming market risk by virtue of technology, trying to see things through the lens of pragmatism. Here's another perspective that reframes deep tech as an approach that revolves around the business model and doesn't aim to fit technology to a hypothetical problem, but instead is implemented as a closed loop process. So in the end, these deep tech companies still face the same business challenges of any startup, but they also need to navigate the additional complexity of technological risk, albeit with the hope of a larger future payout. But this basically means we still have to look carefully at the market we are targeting and understand how a machine learning or AI strategy can fundamentally become a product. Not only how they can be productized, but how they are monetized successfully. And even today, there are a lot of hypotheses around how technologies like ChatGPT and generative AI for images and videos will make money for their creators. And the truth is that it's not as simple as developing the technology and releasing it into a market that's waiting to embrace it. So, looking at the state of industrial automation today, I want to go into a couple videos that give examples of the types of opportunities that we see on a regular basis at RIOS. So in the video here, you're going to see an end-of-line pack station where people are packing objects into boxes. In this case, it looks like pretty standard beer bottles. And you'll notice that there are a number of stations that cover tasks like box opening, box assembly, box reorientation, picking and placing of objects. There's palletizing, and there's also on-the-fly quality inspection. As people pick up those bottles and put them in the box, it looks like there's a bucket that they're dropping ones that don't pass inspection into for discarding. And end-of-line pack stations like these are a common bottleneck in logistics operations, which are partially but not fully automated. It's not uncommon to see lines of people doing repetitive tasks like this that fill in the gaps in semi-automated processes. I have another example here, which is an item you might be familiar with. And this is a Twinkie factory, and you can see that both quality inspection and packing are happening in the same step. So these workers on the line are grouping the Twinkies together. They're looking at them and they're getting rid of the ones that don't pass inspection. It's a pretty repetitive task that looks like it would be easy to automate, and it's often surprising that today there's still a lot of tasks that are done manually just like this. And there's a lot of commonality between tasks like this and the one we saw before, where objects are coming down a conveyor to a team of human workers who are picking them and putting them into boxes. So these aren't hard tasks for humans, but they can be for robots. And some of the labor challenges have been well publicized. Uh, the jobs themselves are monotonous. They're ergonomically unforgiving, um, and they have a notoriously high turnover rate. As this headline here shows. And the repetitive nature really does seem like a good opportunity for automation. So, you know, as I mentioned, it can be a surprise when you see how much of our manufacturing and supply chains are still composed of manual labor, and they're staffed with these low wage workers. And this is only part of the story, though. This is a leading economist whose name is Robert Gordon, and he's at Northwestern. And he's known for this quote, which is that industrial robots have been around since 1960, and they've been surrounded by a lot of hype. Yet when I travel, I play a game called Spot the Robot, where I count how many robots I see. That number has not changed considerably in the past decades. And this is something that we see all the time at RIOS. We make a lot of on-site visits and walk around these factories, and there's opportunities for automation everywhere. So, how do we overcome the inertia of an industry that seems to be held back by technology? And one of the first things to look at here is around the way equipment is traditionally purchased as part of capital expenditures. So this model defines the sales cycle from budget allocations, approvals, and internal sign-off to installation and integration and even support models. And it has multiple consequences. So I'm going to skip over some of the details here, but a number of factors are important for understanding how we can appeal to a broader base of customers. And you see that these limitations have real world impacts in terms of what capabilities a company might have to automate. And going into customer understanding a little bit, I think there's a scope of application, or there's a scope beyond just the applications, where we want to understand what the customer motivations are. And I think in startup terminology, this section might have been called product market fit, but I think market fit really only comes from deeply understanding the target customer and being able to see things from their point of view. And without actually talking to customers and building the relationships with them, it's really difficult to understand what features or incentives will nudge them in the direction of engaging with your technology. So in our case, the target customers in our box packing examples both came from the food and beverage industry. But there are many places where packing to boxes is a key process. So this slide has a few examples of potential target customer categories, along with an example of their core business objectives. And the details aren't important here, but I'm using this slide just to make the point that although automation is an important factor in the success of all these businesses, it isn't the main objective for any of them. They each have their own areas of specialization. And furthermore, some of the parts of the automation process are harder to automate than others. And advanced automation of complex tasks requires really deep technical expertise in robotics disciplines like computer vision, motion control, and systems engineering. And the tasks that need automating today need the expertise of companies that specialize in developing advanced robotic solutions from the ground up. So, just getting a little bit deeper into the problem, one of the types of challenges that makes robotics hard is the diversity. And that kind of manifests in multiple dimensions. And despite the commonality that we saw in the videos, there's a lot of diversity that could be more subtle and often very specific to an individual line. So, here's some variability in applications that we might look out for. It's not a comprehensive list, but it includes things like box types and sizes, how box and objects are delivered to the line, the way that objects are packed in boxes, the working footprint, the process flows from one piece of automation to another, incoming regularity of objects, adjacent equipment such as conveyors, software and hardware interfaces to existing automation, and even the level of automation in the factory. So that list kind of goes on, and I wanted to show a quick video of something that comes from our research and development labs, where we're actually testing a real world system, and it shows some of the diversity from the previous slide as part of the testing that we put our robots through. So the system in this video was under development at the time, but it's since been shipped out along with other identical units and deployed to customer sites, and we know these are working reliably out in the world. If you look at what's happening here, there's a number of different types of objects that are traditionally hard for computer vision and perception systems to deal with. So some of these items are transparent. They have high reflectivity. That makes them very difficult for depth cameras to understand, for instance. If you look at the box itself, the box is completely beat up, and we've reused it over multiple testing runs. And these are the types of things that we see in real world conditions, but this actually represents conditions that are worse than what we'd expect in the real world. And this is because we want to identify any failure modes we can before the system ever ships to the customer. We've learned that you can't over prepare for the long tail of edge cases that you might run into in robotics. So, operating under conditions like these is a challenging problem, and dealing with the many variations of product geometries, materials, specularity, and environmental dynamics is where we need to leverage methods like state-of-the-art machine learning in order to complete the tasks. So as a quick summary of our customer introspection, there's a few takeaways that we came up with. One is that the current industrial solutions are built around large CapEx purchases. Our target customers are not robotics experts, and then traditional solutions aren't suited to the variability of conditions and tasks and integrations. So, I think the question that we often ask ourselves at RIOS is, how do we transform this, which came from that first video? We can see quite a few people, doing repetitive tasks in a semi-structured environment, to something like this, where we can fully automate these lines. And one thing I want to clarify is that our goal is not to replace human workers. Our goal is to add value and efficiency to production lines and industrial processes so that businesses can really focus on their core competencies. And what you see most of the time when you bring in these new methods of automation is that people end up in better jobs that aren't nearly as repetitive. There's an effort to upskill workers, and train them for other things where they can be more effective. So going back to the CapEx diagram from earlier, I want to look at a couple bottlenecks that we've seen where we can notice that there are things out of our control when we're trying to sell these products or sell this technology as a product. And so, a few of these at the bottom are capital expenses, the budgets and approvals on the customer side. And there's some things that we could take a larger role in as a company to provide a better customer experience, including things like installation, integration, service, and support. And if we did that, that would create a better experience for the customer. And the other thing to consider here is that, although, we're going to share that ROI ultimately, if we can bring efficiency gains, then we might be able to actually offer a better ROI and make kind of a more profitable business for both of us. So there's a couple categories here that will change on the next slide, and I just wanted to highlight those. When we move into an OpEx or a RaaS model, and RaaS, if you're not familiar with it, is robots as a service, and it's effectively based off of the SaaS model. And this is quite a bit simpler for the customer, and allows us both to focus more on our strengths. And so, a couple things that you might see here is that we've taken over a lot of the installation and integration, and we can offer better support and better service along with that. We also have changed the capital expense to an operating expense, which allows more people to automate. And that ROI gets kind of split up into multiple different factors. So we can actually add value or value-added services around things like data, process optimization, and efficiency gains that weren't possible before, simply because they weren't even being measured. And so this just kind of highlights a couple of the changes. So, the capital expense turns into an operating expense. The budgets that you need to be able to bring in automation decrease, and the amount of approvals you need, because those dollar amounts are lower, goes down. And that ROI gets kind of broken into different categories, and the customer no longer has to deal with installation or integration. And so this is just kind of a quick summary that, based on the previous slide about CapEx limitations, that shows by providing options for OpEx transactions that are modeled after SaaS, we can resolve a lot of those limitations of the CapEx model and offer a better product overall. And then another way to look at this is through the lens of addressable markets. And so, I think most people are familiar with the TAM, the total addressable market. There's another few subcategories one being the serviceable addressable market, which is the portion of market you can acquire based on your business model, and then the serviceable obtainable market, which is a percentage of the serviceable addressable market, which you can realistically capture. And effectively, what we're doing is expanding the amount of customers that we can reach with our technology by innovating on the business model. And so I'm going to get into a few of the implications for AI and ML development based on this new business model and perspective on the industry. So if you look at traditional automation under CapEx models, and look at a few of the limitations there, we have solutions that are application specific and not made to generalize. They provide little or no incentive for updates once they're installed. They're served on device or on site behind firewalls. They're difficult to remotely monitor and debug, and they offer limited or no support. As we move to as a service models such as OpEx or RaaS, we can provide the model itself provides incentives for more general solutions from our end, because we're servicing multiple customers. It provides incentives for updates, such as continued machine learning model development. These models are better served via scalable cloud-based infrastructure. They can be remotely monitored and debugged, and they have support models built into them. And so, this isn't to illustrate selling points, but to actually show how objectives change for machine learning development. Traditional robotics and automation solutions are hardwired for specific tasks, and they're not connected to the outside world because they aren't designed to handle updates. So when we introduce recurring revenue models like RaaS, we need to offer support and upgrades which benefit both RIOS and the customer. And we move into a world where industrial automation is connected to the web, and we can deploy robots with the same technologies we build social media platforms on. This really makes robotic platforms more scalable and leverages the same technologies that have made data-driven deep learning models so successful. And there's also there well there's a side note of a thing that of a topic that's kind of popular within machine learning right now, in terms of uh, understanding what's happening, which is there's a short paper called the hardware lottery that just talks about how repurposing web technologies has described why a lot of the current methodologies are being used, because when they are suited to the available hardware and software, um, those ideas tend to win in the end. And so one way to look at this is through the lens of uh, advancement in other fields converging and actually giving us the capabilities that we have today. So with that, I just want to get a little bit into what RIOS is offering, and talk about some of our solutions. So at RIOS, we've been developing modular components for both software and hardware that allow us to quickly deploy robots to factory lines. There are a few shown here that each perform a different task, and they can be assembled in an end-to-end solution we call a generalized pack line, or GPL. That GPL itself can be replicated and deployed as well. So some of the components do things like materials or food handling, assembly, pack to box, quality control, and inspection. And you can kind of see here that they each have their own individual functions. This is a representation of how you might assemble these to become a generalized pack line. And you can see that we really offer a complete end-to-end solution for automation. And ultimately, when we put these together, we can fully automate warehouses. And this here is a bit of a nice rendering that shows our vision. But the really cool thing is that these robots exist in the real world, and it's not just conceptual. Uh, you know, a lot of the industry is sort of built around this deep tech mindset where people are developing research in labs, and it never really makes it into the real world. Um, we're building, designing, and iterating on each of these designs and actually testing them out in the field. And they're meeting real world KPIs in some of the most difficult environments you can imagine, as I showed earlier. So these are some images of our robots deployed in the real world, and that's all I have for this presentation. So if you have any questions, I'm welcome to answer anything I can, and you can get more information on what RIOS does at rios.ai, and I also have some of my contact info there as well.
Hey, Matt, thank you so
Hi.
much for that. Sorry for the few little tech issues we were running into. But
Yeah.
nonetheless, that was an awesome presentation. I appreciate you taking the time.
Thanks.
I have a few questions for you, but I don't want to be greedy, and I'm going to let the audience kind of ask questions first. But while we wait for some questions to roll in, where can people connect with you offline?
Yeah, I mean, I think I guess any of those links there. So I guess if you could send me a DM on Twitter, or matt.shaffer@rios.ai is my email.
Awesome. Sounds good. One question that I have while we wait for some of these questions to come in is that I've been asking some of the speakers, mainly just one, since you're the second one. What is one piece of advice you have for founders in 2023 when thinking about some of the topics that you spoke about? I mean, how should they be preparing? How should they be educating themselves? This is a new world, right? So how can founders better prepare for the technology embracement that's coming ahead?
Yeah. Well, I think, from my perspective, it really comes down to that, build, test, design, iterate cycle where, you have to get products into the real world and you have to test them with customers. Um, if you don't do that, you're really missing a critical piece of feedback that, somebody who spends a lot of their life around machine learning and robots, it seems pretty obvious, but in order to optimize a system, you have to close that loop. So I think as I mentioned early in the presentation, a lot of these investors are really looking for a path to profitability, and the way to do that is really just through directly engaging with your customers.
I agree. I agree. I'm a true believer. I come from a growth marketing background, so it's always about experiment what works, double down on it, what doesn't work, but also just more importantly, being able to market or measure everything that you market, and having a process that you can streamline, and systemize so you can automate, right? Because I think that's what at least the AI and machine learning proponent of technology right now is helping us accelerate that process versus replacing jobs.
Absolutely. Yeah. That measurement piece of it that you mentioned is critical.
Yeah, I too many times I've been in scenarios where with early stage startups getting a lot of traction, but they don't know exactly where the traction's coming from, and that's definitely scary long term. But I understand sometimes why it happens in the short term. So doesn't look like we have any questions coming in. So either we can end it right here, or I have one more question for you if you don't mind me asking.
Sure.
What, given that you are, you have a really intriguing position, what is one myth about machine learning, or AI that most people don't know about, that, or just something that is an uncommon piece of knowledge that you know about that most people don't know about?
Well, I mean, I guess I would say, from my perspective, that there's a lot of weight and emphasis put on algorithms as solving problems, and there's no doubt that they're important, but especially when you look at the robotics industry, the things that are advancing the robotics industry are a wide range of different systems working together. And so a lot of the system advancements, the computational advancements, there's been a lot of hardware that's come out in the last few years that's really enabled machine learning, and I think it's really easy to discount that when you see all of the publicity around algorithms. So I think that would be my yeah, maybe that's the thing I think people just overlook. I don't know if it's totally something only I know, but I think the larger community often ignores it.
No, that's really interesting. You said that. I was recently at a networking event here in Dallas that I was hosting, and we teamed up with this robotics lab, and they have a partnership with is it Boston, MIT? I don't know which university has a big robotics program.
MIT generally has.
MIT.
Yeah.
So yeah, they teamed up with them, and they had these robotic dogs that were insane. It was they were so smart. I mean, they're basically going to be utilized to two things. One was to as a security measure, to replace security dogs or security guards at night, just because of the accessibility. But two, in case of if there was the example the founder was talking about was if there's a chemical fire, at a chemical plant, they can send the dog in, because usually it takes anywhere from 20 to 40 minutes, and just thinking, obviously someone that's always very curious about things, I let my brain start running with that. And I was just wow, the things that this will help solve and the money that it's going to save. It's just, it makes, I think in my unprofessional AI opinion, it's there to eliminate human error, or minimize human error, right? Because that's one of the most valuable things that companies have is human capital. So helping minimize that so you can increase productivity and revenue and all the other great KPIs that you need to hit.
Yeah, definitely. Yeah,
Awesome.
and Yeah, I mean, I think those, yeah, there's a lot of really interesting work coming out of, like Boston Dynamics and so forth with these robots. I think the business models for those are still developing. So yeah, it'll be interesting to see, how ubiquitous they become.
Yeah, I mean, it's going to be really interesting to see what the world looks like in the next 3 to 5 years. I mean, with how fast technology is adapting and evolving. So I'm very excited for it. But I really appreciate you taking the time today to join us, educating us and sharing some insight about some of your work and some of the things that y'all are working on. So I wish y'all a lot of luck. Best of luck in 2023. Much success, and I'll connect with you offline. I think I might have did right before we hopped on. So. Matt, any last parting words before I let you go?
No, that's it. It's my pleasure being here. Thanks for inviting me.
Thank you very much, Matt. Have a great one.
Yeah, you too. Take care.